Oh, hi there, and welcome to Physics with Malik.
NLP!
Okay, so when we were kids, we used to play with yo-yos a lot, and realized that the yo-yo wasn't really going any faster when it turned. So we thought that there wasn't an acceleration, but as we learned in physics this year, there was an acceleration. So this leads us into our first question. The first question is, what is the difference between linear acceleration and centripetal acceleration? Which one is the velocity constant? So linear acceleration is the rate of change. Okay, so acceleration itself is the rate of change in velocity. That's what it's called in layman's term, and it's simply how faster I'm going, how I'm speeding up, or how I'm speeding down. So in linear acceleration, as I just said, it's either how much faster I'm going or how much slower I'm going. But this isn't the case in a centripetal acceleration, because in centripetal acceleration, the magnitude of the velocity is constant. However, the acceleration is simply changing the angle, I guess you can say the angle or where the velocity is happening. So it's happening as the direction. Thank you.
You're welcome.
And the acceleration is always is acting towards the center of the centripetal force. So our second question is, what is the relation between radius and velocity if centripetal force remains constant? Be sure to explain your answer with a graph sketched on a piece of paper or on a board.
Well, first of all, when the formula for centripetal force is Fc equals mv squared on r. This means that there's the radius and there's the velocity and the mass. Let's say we keep the mass constant. What would happen if we were to change the radius or the velocity? It would follow this kind of graph. What this means is that when since it's a proportional formula, when the radius goes down, the velocity also goes down, and it follows the radius. When the radius when the object spins faster, to keep the same FC, you have to have a bigger radius.
Okay, our next question is, how does velocity affect Fc? So the formula, as we know, is Fc equals mv exponent 2 on r. So as velocity increases, assuming that centripetal force will stay the same, then your other constants would have to change too for you to get the same Fc. But as the question doesn't specify it, I'm going to assume that Fc changes. So if velocity changes, and because it changes exponentially, the Fc will also be affected exponentially. So for example, if the velocity is doubled, well, your Fc is quadrupled because it's v exponent 2. Our fourth question is, how does mass affect Fc?
Well, how does mass affect Fc? First of all, Fc, we always know what it is. It could be either Fg, Fk, Fn. All of these formulas are either m times g times mu, or in the case of Fn, the m times g. They all have an m. This means that they cancel out on both sides of the equation. Fc equals mv squared on r. Hence, there's no more m on either side, so changing the mass would not change the Fc.
That pretty much sums up Physics with Malik.
NLP!
Thank you.
So for question 3, yeah, we changed studios, just we'll put it like that. It says that the mass, how does the mass affect the Fc? Well, the mass affects the Fc because the tension that the Fc procures to the mass varies depending on the mass of the object. Therefore, a higher mass will give a higher Fc. It's a 1:1 proportion.
Alright, so now we're going to discuss a bit about the results we had. So in the first experiment we did, we just took, we changed the radius whilst keeping the hanging, both the hanging mass and the rotating mass the same. So in our equation, Fc equals m times v exponent 2 on r, m was constant. What we realized is that the v was varying, and so was our r, obviously, because we kept changing the radius. This effect is that they both compensated for each other and gave a centripetal force that was equal. So we received the same centripetal force for no matter the length of the radius. Furthermore, in our next experiment, what we did is that we had a consistent radius, and we changed the mass that was going around. So for the lighter mass, we got one centripetal force, and for the larger mass, we got the same centripetal force. The reason for this is the same thing, is because now your m became a variable and your r became a constant, and what that changes is that your r becomes a constant and your m is varying to your v. So as v changes, so will your mass. So they both compensate for each other, which gives you a centripetal force that is equal.
So we used the formula F equals mg to find the centripetal force. And what we did realize, though, that there was some variation. This should be either by imprecise turning or the other friction force that were present on the tube while the rope was spinning.
Also, the experiment in itself has so many small errors, such as using a small pin to make sure that you have the correct radius. And it's basically we're using our eyes to determine that the pin doesn't move, which is very imprecise. Thank you. That was Physics with Malik.
And